All right, so now we're going to go over some problems that I think are pretty common, I should say, and the free response on any AP Calculus test. Now, for you guys listening to hopefully only 2020 year here, is that some of those formulas, right, you can actually write down. So make sure you do your stuff you must know cold and then look at it, all right, as we're going through this. Now, the first part we're going to talk about is the derivatives, or excuse me, the integration using data, right? So a lot of the times this free response questions will have a problem like this. Now, I can't promise you this will be exactly the type of question you're going to have, but I'm almost willing to bet money that you're going to have a question like this. Okay, so first of all, notice that we're talking about, and normally, by the way, on the question, it wouldn't actually say integration using data, right? It would just start off with the question, which is, let me switch to a different color here. The water is flowing into a tank over a 24-hour period. The rate at which the water is flowing, all right, so that's kind of a key word there, right? Key word there. So the rate at which the water is flowing into the tank at various times is measured, and the results are given in the table below, where R of T is measured in gallons per hour. So if that didn't give you a clue, the word rate should, in your head, you should think derivative, okay? And if you didn't get that, just look at the units. Gallons per hour. That per hour, per time, normally indicates a derivative, all right? So, and T is measured in hours. The tank contains 150 gallons of water at T is equal to 0, and that's actually very important, all right? So here's what's going to happen, okay? Here's what you need to do always, right? Which honestly, even I don't do all the time. You need to absolutely read the entire problem carefully, all right? You leaving something out like 150 gallons when 150 gallons of water when T is equal to 0. If you leave that out, for example, you would get every one of these next few problems wrong, okay? So you really, really got to pay attention. So now notice that question A says estimate the number of gallons, all right? So number of gallons, that's kind of a clue there, of water that have flowed into the tank over the 24-hour interval by using the midpoint Riemann sum with 3 subintervals and the values from the table. Show the computations lead to your answer, right? So here's the deal. I know that I'm going to have to integrate. Now, when I'm doing this, right, I'm not going to be able to do I'm not going to be able to work out an integral because I don't have a function. I don't know what the function is for this, all right? So that's what they ask you to do, the midpoint Riemann sum, all right? So what you would write first, okay, and this is the part that a lot of you may get this wrong. You started off with 150 gallons of water in the tank, so you have to add that into your equation. Now you're going to add the integral of whatever this function may be between 0 and 24. So this right here, right, so we're clear, this right here represents the amount of water that went into the tank over a 24-hour period. Okay, so one more time, I'm going to say it again. This right here represents the amount of water that flowed into the tank, okay, over a 24-hour period. All right, so now let me get rid of that. So now what we're going to do here is we're going to start off by saying 150. Now the midpoint Riemann sum, obviously, either you're going to know it or you're done at that point, right? I would highly suggest writing it down. And notice that it says that it's 3 subintervals. Now, it doesn't really tell us, all right, if this intervals are even, and you have to be really careful with that. In this case, they happen to be even, all right? So what am I saying? All right, what I'm saying is that the spacing between these numbers up here is the same. They're going up by 4s, okay? So in that case, you are able to use this exact formula, all right? So I'm going to write a lot of the formulas you may or may not remember, where delta x normally is the width of the rectangle, right? And b is 24 minus 0 all over 3, because I want 3 subintervals. That's what the n stands for, and I'm going to get an 8. All right, so now what that means to you is that the width of every rectangle is 8, so I'm able to actually factor that 8 out, and then now all I have to worry about is writing the heights, okay? Now, in this case, when we talk about the midpoint Riemann sum, right? Notice that this is what I did. Now, you don't have to do it like this. I do like it. All right. Even if they didn't tell me that the subinterval were 8, I could have figured that out just by doing that. Okay. So notice that I have 3 little boxes, if you will. Okay. All right. So the midpoint is actually going to be right in between. Those are the points right there. Okay. And remember, I'm taking the height. The height of each rectangle is represented by r of t. All right. Which in this case is 8.8 plus 9.2 plus 8.1. Okay. So now, at that point, obviously, you're going to have a calculator. Okay, so just go ahead and plug that into your calculator. Don't be a hero. Don't try to do this by hand. Okay, and notice that I want you to write the units. Now, the units are important because it tells you what you got, all right? I didn't get a derivative back. When I integrate the rate at which the water is flowing, I get the amount of water that's in the tank. Okay, so here's the idea. So now perhaps I'm talking too much. But let's say that I don't know, is this going up the whole time? Let's see. Okay, more or less. Let's say that it was going up. Okay, so then let's just leave it at 2 okay, let's do 3. So this is not about this problem. I want to just make sure we understand one another. So since this is R of t, which is represented in gallons per hour, and this bottom crap is represented as time, which is represented as hours, how would I figure out the area of this rectangle? Well, I would just multiply the width, and let's call this, in this case, let's kind of keep it the same, I guess. Let's say that it was 8, all right, but this is going to be 8 hours, okay? And when I multiply that times the rate, which is in gallons per hour, so let's say that the first rate was 8.8, so I'm just doing the first one. And this is gallons per hour. The hours would cancel and end up with gallons. That's important, right? So when I integrate something, like let's say that I'm integrating velocity, right? The units are miles per hour. But if I integrate that, then I'm going to get back to miles because I will be multiplying that time times a rate. And that's going to give me just, in this case, gallons. All right, so hopefully that makes sense. So make sure you write the units. Right, so on number 2, it says estimate the number of gallons in the water tank at the end of 24 hours by using the trapezoidal sum with 3 subintervals and the values from the table. All right, so at that point, we're doing the same thing, okay, but we're going to use the trapezoidal sum. Now, the trapezoidal sum for some people is really hard to remember. Now, for some of you, if you happen to be listening in the future, right, for the 2020 exam, well, you can actually just write those down if you like. But the formula for me has always been kind of easier to remember because I remember the formula of the area of a trapezoid. Okay, so sort of like that. Okay, so in this case, I'm going to have, again, start off with 150. Why did I write 150? Because that's what the water, the tanks, that's the amount of gallons the water started with. The amount of gallons that the tanks started with. Hopefully I said that right. So now the formula for this is going to be 1/2. Now the height for this, since we are talking about evenly spaced, right? We're talking about evenly spaced, in this case, trapezoids, the height for all of these is going to be 8. Now I'm gonna go ahead and write it just as trapezoid so you can see that it's really not that big of a deal. And I'll write you what the formula normally looks like, okay? So then I would have 8, so that's the height, and then I have base 1 times base 2, right? So let me erase some of this stuff that I wrote here. Let me erase all of this just to kind of make it clear about what I'm trying to say. Okay. So since we're still using these, okay, I'm actually looking at these numbers now. Now for the right sum, you would use these. For the left sum, you would use these. And for the trapezoidal sum, you're actually going to use all of them, and you'll see why. All right, so the first trapezoid would be 8 times 8 plus 9.3. That's base 1 and base 2. Plus 1/2. Again, the height is going to be the same for all of these, and this would be 9.3 plus 8.9. Then I would have 1/2. Let's see, 8.9. Oops, I forgot the 8. Maybe I didn't. 8.9 minus plus 6.7. Okay, so you can type it on your calculator like that. I don't care. All right. Normally the formula is going to look like this. So just be aware that what happens here is that these numbers, line 9.3 repeats, 8.9 repeats. So normally the way you could write it, if you factor out, notice that all of these have a common factor of 1/2 and 8. All right. So you could have written this like this also, and that would have been just fine. Now the middle stuff, that's why we actually write a 2 in the middle. So we're going to put the 2 in the middle there. So both of these are exactly the same, okay? So when you actually do that, you get 354.4 gallons, okay? All right, so let's go to C now. Okay, so it says a model for this function, all right, the function that we have above, which we call R of t, is given by W of t is equal to that function. Use the model to find the number of gallons of water in the tank at the end of 24 hours. Okay, so number of gallons of water in the tank. Now, they are going to assume that you're going to have a calculator, right? At least they've said so far. So what you would do, all right, so you get credit, is that all I have to do for now is integrate that function. Because this function right here, remember, just like R of t, represents the rate at which the water flows, and hence the word rate. That's a derivative, right? The rate at which the water flows into the tank. So therefore, all right, we're going to say all you have to do to get credit, assuming you get the right answer, all right, is write this. You could write the whole equation if you like. Doesn't matter. Right, but at the very least, you have to write that. If you just write, and then by the way, then obviously what I'm trying to tell you is just put that in your calculator. Put this. You don't have to write this necessarily for the AP exam, but what I'm trying to tell you is that you need to write all of this. Write this, or put this in your calculator. And obviously you can switch the t to x's if you like. But for the AP exam, all you have to do is write what I wrote on the top there. And then let me not forget the 150. Right? And that's going to give me 357 gallons, 0.36. So all you would have to write for the AP exam would be this. Okay? That's, by the way, and that's the least, and I didn't write the units. It didn't tell me really to write the units. So they really couldn't count that off, but write the units, okay? At least on the homework. If they don't ask you for that on the AP exam, then just don't do it. All right, so notice that right there, that's all I have to write, okay? I want to make sure you understand. All right, moving on. So now we're going to use the model given to find the average rate of water flow. Okay, so this is one that people really like way overthink, okay? But here's the deal, okay? There are two ways to do this. Now, there's really two ways to do it, but there's only one way to do it, really. All right, what we're going to do here is that, remember, when you hear the word average rate of something, okay, then we're either talking about two formulas. The first formula is what we call the mean value theorem for the integrals, I believe. So you could do it like this. You remember that formula? Okay. But don't forget what that really means, all right? And this is the reason I'm saying this for a reason, because you're gonna see how this is easier not to do it like this on the next page. You could do it like this: f of b minus f of a, capital F standing for the antiderivative of lowercase f over b minus a. So that should look really familiar to you. That looks like the slope of a line, all right? So that's really all we're talking about. Now, because we don't really have this information, right? All we're gonna have to do on the calculator, right, is 1 over 24 minus 0. And by the way, and I just want to find the average water flow, right? So do not add 150. Actually, as a matter of fact, that wouldn't make any sense, and I'll show you why. Now, let's make sure we understand this, okay? The answer is going to be 8.64, but what are the units? Okay? Now, this right here, this is the weird part. This right here, when you integrate it, has the units of gallons. But when you multiply that, see that 24 over 0, 24, that 1 over 24, essentially, I'm dividing this by 24 hours. Well, actually, I already did. Essentially, I'm dividing this by hours. Okay, so notice that it says the average rate of water flow. The word rate, you should know that those units are going to have to be per time in this case, okay? So again, notice that this right here gives me the units of gallons, and this right here is going to give me the units of hours on the bottom of the fraction. Okay, so that's the answer. All right, so let's move on. So let's talk about derivatives using data. So same kind of idea, except for I actually find this a little bit more difficult because the other one is just doing the same thing over and over, where these, they could actually ask you very different questions in very different ways. Okay, so same idea, except for now it's backwards, right? Notice that this right here represents the amount of gallons. Okay, they're going into a tank. Now, there are 150 gallons of water in the tank. So same, it almost looks the same, but see that number is already here. So that's already given to us. All right, so let's just read the problem and go on. All right, so it says water is flowing into a tank over a 24-hour period. The amount of water, W of T, in the tank at various times is measured, and the results are given in the table below, where W of T is measured in gallons and T is measured in hours. There are 150 gallons of water in the tank at T is equal to 0. A. Use the data from the table W8 using the appropriate units and explain the meaning of your answer. Well, you just want to know what W8 is, right? So W of 8 literally is equal to just this number. Now, what you could do is, it says basically use appropriate units. Well, since 221 is in gallons, so this is gallons, all right? So what does that mean? Explain the meaning of your answer. Well, what that means is that there are 221 gallons of water in the tank. And the tank at precisely T is equal to 8. And I'm not going to write precisely. T is equal to 8 is sufficient. Okay. Now on B, it says use the data from the table to find the inverse of 257 using a. Okay, so this is, and I actually don't foresee them asking you a question like that, but they could. And basically, this is the inverse at 257. So you basically have to look for 257, which is right here, and look at that number there. So this is 12. All right, so what are the units on that? Okay, well, the units on this one are hours. Now, for the meaning, you don't have to go too crazy here. It's the same meaning as the last one. There are 257 gallons of water in the tank at t is equal to 12. Okay. That's it for that. All right, so let's get to the actual fun part. Now, it says use the data from the table to find an approximation, keyword approximation, of w prime of 15. Show the computations that lead to your answer. Use appropriate units explaining the answer and meaning. Okay, blah, 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 blah. Here's the deal. What this means, okay, is that what we're going to do right now is we are going to try to find the derivative of 15, but here's the problem. I don't even have 15 on the table, right? So a lot of people just kind of freeze on that and they go, well, I don't even have a 15, but we can all agree that 15 would be somewhere here, right? Somewhere in there. So the keyword is approximation. Well, I'm trying to approximate a derivative, and the only way to do that is to find the slope of a line between 2 points. So I'm going to use those 2 points and just find the slope between it, and that's it. All right, so I have w of 20 minus w of 4. Wait, am I using the right problem? No, I am not. I was looking at the wrong part of my key. My bad. 16 and 12. And remember, why am I using those? Well, because 15 is right in between those two. Okay, I guess technically you could use another 2 points, but this would be the two most accurate ones you could use. Over 16 minus 12. All right, so this is going to be 294 if you look at the table. It's going to be 257 over 4. Use your calculator, you get 9.25. Now, what are the units? Think about it. The top part is in gallons. The bottom part is in hours. So this is going to be gallons per hour. Okay? And explain the meaning of your answer. Well, this is the approximate, and this is what I'm going to write. Okay, the meaning of my answer. Here's what that means. This is the approximate rate. Keyword, right? You have to use that for this. This is the approximate rate at which the water is flowing into the tank. Into the tank at t is equal to 15. All right, so that's that. All right, on these says use the data from the table to find the average rate of change, right, of WT over the period of time. Now, here's the weird part, right? Now, where before I told you, hey, try to take the antiderivative of something and divide it by time. Well, in this case, all right, and I want to write you how this is actually the same, but I wouldn't actually even do it like this. I would have to take the antiderivative of w prime of t, and then after that, I would have to divide that by, let's see, 20 minus 4. I guess that goes. But I'm not going to write it like that, okay? What I want to do is just have to think about it. What is the average rate of change? You need to go back all the way to Algebra 1, but you need to understand the connection. The average rate of change, all right, all they want to know is basically the slope of a line between 2 points. So this right here is what I would write. And by the way, this would be equal to that, okay? So that's how they're related. And this is the part that I wish I was in class because I think you might understand that better if I were in front of you, because I would try to drill that into your head. All right, so if you actually put that on your calculator, let's see, you got 327. So minus 184 over 16, which is 8.938. And please do not forget to round to 3 decimal places. All right, that's that, guys. Do I have to? No, we don't have to explain the meaning of my answer. Good. Okay, so now So notice how they're very similar, right? The questions. All right. So on E, between 0 and 24, there must be a time T where the tank contains 265 gallons of water. Okay. Justify your answer. So this comes down, and this is what you really need to know this theorems. Okay. Now, a lot of you are going to intuitively and understand this, right? Now, we're talking about water flowing into a tank, so we can assume it's continuous, right? Now, it's asking you, must there be a time? Is there a time? Whoops, I'm trying to erase, and I don't know why it's not erasing. Okay. I'm trying to figure out a time, if there is such thing, right? If there's a time where you have 265 gallons of water in the tank. Well, look at it, right? Probably at least in between here and here. How do I know that? Because to get from 257 to 294, you must have gone through 265, right? Does that make sense? Yes, Mr. Ochoa, that makes sense. Great. All right. So, well, there's a name for that. All right. So you can explain everything, and a lot of you are going to go into this elaborate explanations like of what I literally just said. But what you have to say is the following. All right. Oops. Let me minimize this. Since W of t, and yes, you do have to say this, is continuous and differentiable. All right, meaning there's no breaks, no peaks, no nothing, okay? Since Wt is continuous and differentiable, then by the intermediate value theorem, all right, which we can actually just abbreviate to IVT, by the intermediate value theorem, okay, there must be at least one time where the tank contains 260. So basically, I'm just rewriting this. $265 gallons. Okay, so that's that. Again, that's a very important theorem to know. The intermediate value theorem, right? Absolutely important. All right, so let's move on. So now, let's see, F. Okay, so a model for the amount of water in the tank is given by A of T, blah, 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 blah. So remember, now this A of T actually represents the amounts of the amount of water in the tank, right? The units, of course, is gallons. So now, it's asking us now to write a prime of 15. So remember, you're going to do this in the calculator, right? And if you're using an 84, which I cannot show you, all you would have to press, I believe, let's see, I think it's math number 8. Let me check. Let's see, math number 8. Whoops. Yeah, all you have to press is math number 8, fill that in, and then put the 15 in there, right? So what do you have to write for the AP board to give you credit? All you have to write is this. Don't just write the answer. Again, don't just write the answer, all right? Write at least that, and then plug it in your calculator. And please don't put it on there. I use my calculator and then put the answer. They're not going to give you any credit for that. Or at the very least, they're going to count off of that. Right? The units is going to be gallons per hour. How do I know? Well, because A of t was in gallons. So when I take the derivative, I'm going to have gallons per hour. Similar to position, right? The derivative of position is velocity. How is velocity measured? Well, many ways, but one way is like miles per hour, for example, right? All right, let's go to G now. All right, so I'm at the end of this. So now we're going to find the average rate of change of A of t over the period of time of blah, 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 okay? The easiest way to do this, okay, I'm going to show you two ways. On this one, you really could do it two ways if you really wanted to. But one way to do it is just what I show you up there. Average rate of change, and A of t is already in gallons, okay? So all I would have to do is write A of 20 minus A of 4 all over 20 minus 4. All right, and then you kind of do the math there. A of 20, of course, you're going to have to use this formula and plug in a 20. I think that gives you the following. And I'm keeping more decimal points because I want to make sure that by the time I round to 3 decimals, I don't have a rounding error. So I normally don't round until the very end. Oh, shoot. I'm out of space. Three decimal places, gallons per hour. Okay, now the other way you could have done this, actually, I think more difficult, but I mean, I guess you could do it. This is not impossible. And honestly, that just seems too complicated. But what you would do is I would take the integral of the derivative of a prime of t. So basically the derivative of this between 4 and 20. So this is the mean value theorem for integrals here. But notice that literally gives you what I wrote here. Okay, so I know that last part could be a little fuzzy. So make sure after you watch this video, ask me questions, all right? We only have 2 weeks until the AP exam. So you got to ask those questions. If there's something you don't really understand, then you really need to ask me that, okay? All right. Other than that, guys, again, make sure you do your stuff you must know cold, fill it out. All right. Look at it, study it. Make sure you know where those things are at. So on the day of the test, you can actually look at it quickly without having to figure out how they work. Okay. All right, guys. Until next time, please let me know if you have questions.